First of all, let's define a couple of terms for our purposes here. The first is thermogenesis, an increase in metabolic rate and lipolysis. And the second is synergy, the phenomenon by which the combination of different agents provides an effect that's greater than additive. Plants contain many different types of compounds, and the ones we're talking about here are in the alkaloid family. Some are direct and indirect acting adrenergic agents such as synephrine and octopamine from bitter orange, and methylhexanamine from sweet-scented geranium oil. Adrenergic agents with beta-agonist activity can stimulate thermogenesis in some people, thus increasing the removal and oxidation of fat from adipose tissue stores, an action potentiated by methylxanthines, such as caffeine present in green tea. Let's run that by you again. Most people think of caffeine as the prime mover. Indeed, it's the most widely used thermogenic agent in the world. But in our model, it's in a potentiating role, not a primary one. Indeed, we like the kind of synergy science that shows a greater effect using small quantities of a variety of compounds than using a huge dose of one, much less potential for adverse effects. Here's something else we're using, a velvet bean. This contains L3,4-dihydroxyphenylalanine, better known as L-DOPA, a precursor for the endogenous catecholamines that mediate thermogenesis in peripheral tissues and act as neurotransmitters in the central nervous system. In dopaminergic pathways in the CNS, the L-DOPA from velvet bean can increase dopamine availability, while aporphine alkaloids from sacred lotus can mimic the action of dopamine. Since we know that dopaminergic pathways in the CNS may modulate eating behavior, we find that SmartSlim may be helpful in supporting not only thermogenesis, but reward response, mood, and satiety.